Hello, everyone. This is Shauna, and I'm here today to record a homework problem that I think might pose some difficulty for you. It involves finding areas between curves. It might have been a while since you've done it. And if it was like most experiences in Calc 1, it was toward the end. And so it was kind of rushed. It involves finding areas between curves, also using integration by parts to evaluate the resulting integrals. So let's take a look at problem 63 from 7.1. It says this: find the area bounded by the curves, find the area bounded by the curves y equals x squared natural log of x and y equals 4 natural log of x. Okay, what you see on the screen is my solution to the problem. Before we get more into that, you have a kind of a graph over here that is kind of jerry-rigged. This curve that you see going up and to the right is 4 natural log of x. It got cut off when I took the picture. But that's 4 natural log of x. This other curve that comes up is x squared natural log of x. What I'm going to do is share my Desmos screen with you, and you'll be able to get a better picture of this. This red curve that you see on the screen is 4 natural log of x. The other curve, the blue one, is x squared natural log of x. And as you can see, they have two intersection points, 1 and 0, and 2, and approximately 2.773. If you plug 2 into the curve, you find out that that's 4 natural log of 2, which for our purposes is a better expression, but we want the intersection points of this. If you get this problem on the test, you can graph it to find the intersections, but you have to be able to show the algebra. So I'm going to go back now to my solution here. We're going to find the intersection points. We know from the graph that there are two of them. Okay, so set them equal to each other and then factor out the common factor, which is the natural log of x. 4 minus x squared is equal to 0. Now, something to be aware of here, I'm dealing with the natural log of x. So I know that my domain has to be greater than 0 here in order for this to work, even though the math gives me other solutions. So natural log of x equal to 0. Use e on both sides. Write this in exponential form. E to the 0 is equal to x. So x is equal to 1. And then use factoring or the square root property here. I used factoring to get x equals 2 or x equals negative 2. The value of negative 2 is excluded because it's outside of our domain. So we have our intersections. They are 1 and 2, and we can see that from the graph that I showed you previously and from the graph that you see here, 4 natural log of x is always above x squared natural log x in the interval from 1 to 2. So when I write my integral to evaluate the area, I'm going to say that it's the integral from 1 to 2 of 4 natural log of x minus x squared natural log of x dx. Now, you don't have to write this as two integrals, but because I needed parts on both of them, I didn't want to write it as one integral and try to do parts twice and show that. So I'm going to end up doing parts twice, but I ended up treating this as two problems. So both of these integrals require parts to evaluate, as I said. for the integral 4 natural log of x, yes, I could have pulled the 4 across. I elected to leave it in. If you have the integral of the natural log of x memorized, good for you. You just multiply it by 4. But if you don't, here's the work. U is the natural log of x. Because again, if I don't make u the natural log of x, then dv becomes a natural log of x, and I have to integrate that anyway. So it makes more sense for this to be the logarithmic function. dv is 4 dx. Don't forget your dx there. Differentiate u, you get 1 over x. Dx is du. Don't forget your dx here because this is du, the differential. V is the integral of dv, which is why we need dx, and we get 4 x for that, because the constant has a 0 power, so the integral would have a first power, which means we need a variable there. Then the integral from 1 to 2 of 4 natural log x dx, this is uv, so ln x times 4x, which I have here from 1 to 2. The integral from 1 to 2 of v, which is 4x, du, which is 1 over x dx. Okay. Simplify your integral, your definite integral on the right. 4x times 1 over x is 4 dx. And then, yes, integrate that again. So you get, this is going to be 4x from 1 to 2. And then go ahead and evaluate with the fundamental theorem of calculus. Remember, your upper limit goes in first. So you have 8 ln 2 minus 4 ln 1, okay, minus 4 times 2 is 8 minus 4, okay? Remember that it's minus the entire expression. Okay, I'm going to leave that for now and come over to my other integral, because remember I had the integral from 1 to 2 of x squared natural log x. Very similar. We have u is natural log x, dv is x squared dx, du is 1 over x dx. V this time, I integrate x squared, is 1/3 x cubed, or x cubed over 3, whichever way you prefer. This is uv, which is ln x times 1/3 x cubed from 1 to 2. Then v du is going to be 1/3 x cubed times 1 over x dx, and it got cut off by the edge of the paper. Sorry about that. This is going to be 1/3 natural log x from 1 to 2. If you simplify here, you get x cubed times x is going to be x squared over 2, but then I have to integrate that. So I have 1/3 x squared, and then I have to integrate this, so that's going to become x cubed over 3 again, but I already have a third. So I get 1/9, because I have 1/3 times 1/3 x cubed. So 1/9 x cubed from 1 to 2. Then I plug everything in and evaluate my integral. So if I plug in the 2, I get 8/3 natural log of 2 minus 1/3 natural log of 1. Remember, the natural log of 1 is 0. So that canceled. And then I have minus this minus, this middle minus next to the 1/9 is this minus that you see in front of the parenthesis. So 2, that's 2 cubed is 8. So this is 8/9 minus, because remember we have to subtract the expression that we evaluated at the lower limit, minus 1/9. So if you work that all out, which you can't see down below, you have 8 ln 2 minus 4. And then this is minus 7/9, okay? 8 ln 2. And you have minus 4 minus 7/9. So it's going to be, this is going to be, when you work it out, it comes out to 16/3 ln 2. Now, why is that? Because you have 8 ln 2 minus 8/3 ln 2. So you have to get a common denominator there. 8 ln 2 is the same as 24/3 ln 2. 24/3 minus 8/3 is 16/3. So 16/3 ln 2. Then you have negative 4 minus 7/9. So you have negative 4, okay? And it's negative 4. It's going to be negative 36/9. And then you have plus 7/9 because it's minus this. So it's 16/3 ln 2 minus 29/9. So let me write this on the, this is going to be, let me type text. This is going to be, let me type it up here where you can see it. So it's 16/3 ln 2, 16/3 ln 2 minus 29/9. Oops. 29/9 is my answer for that. And again, comes from 8 ln 2 minus 8/3 ln 2, right? That's 16/3. Then you have negative 4 minus, this is already negative 4 minus 7/9. So this is negative 36/9 plus 7/9 is 29/9. Okay. So my answer here is this. 16/3 ln 2 minus 29/9. I hope that helps you, and I'll see you in my next video very soon. Take care, everyone. Bye for now.